Okay, so today we shall start a new from on. Okay. We want to start today a new module. The module is the last module, module 5, which is on approximation algorithm and randomized algorithms. So I hope there is nothing much in your syllabus. So that means you don't have to cover that much thing. Okay, but still approximation algorithm or randomized algorithm is a huge area, another separate specialization. Okay, but we will very briefly talk about this module, okay, as per the syllabus. Okay, so um, today's lecture is on approximation algorithms, part 1. So let us go for today. We shall be talking about some examples to motivate ourselves. So let's consider this problem: area of a region. Okay. So what is the problem? Means consider circle, circular region circular region of which area is to be computed. So means in the figure, let's say we try to draw a figure here, compute it. And this is the area. Radius, right? The radius is r. Okay, and we know that its area will be, and the radius of the circle r units, then its area given as okay. So this we know. Okay, so AC equal to pi r square. Now just I just want to ask you, uh, okay, a very I mean one question, that is area of a circle is pi r square. That's fine. So area you can compute only when the radius r is known. But what if how can you? Is first question is, can you compute the area of its radius is unknown? Okay, so I do not know the area r, the radius r. So in that case, how can I measure the area? So you can think of it. That's my question. Okay. Okay. So the answer to this question is answer probably. question is, how is it possible? Okay, so you may find, um, you may Google it, find some ways to compute area of the circle where the radius is unknown. Okay, that's fine. But okay, so and ultimately we found a technique to compute its area, and let it be, later on we will use this, that's why. So fine. Uh, okay, so this is the area of fine. So ultimately we can find the area of the circle. So we will use this to come up to another question, but let me tackle this situation. Okay, so one way I can show you, that uh, is probably be our first motivation why we are studying, we are studying this kind of topic, approximation algorithms. Okay, so one way, one way to compute the area is as follows. Construction is inscribed inside. Okay, some square. Okay, so I hope. Okay. Okay, so you have done that. So this is the square of length A, the side A. Okay. A unit, A unit, A unit. This is also. Okay. So now, as we are constructing the square of side A, so that means A is known to us. So area of that, area of the square, let's say S equal to of S, fine, S. Now what we are doing, okay, and from this situation we can find somehow the area of this circle. Okay, so even if using this way, in this way we compute the area of the circle, still you may argue that sir, I mean, we are just finding the area of the circle, so what's the big deal in this? Okay, so it's a circle only, somehow if I can measure, uh, I mean, you may also do this. Let's say you can find a diameter. You can draw, construct a diameter like this, like okay, like this. Okay, okay, fine. Okay, so within this region, if you find, so draw, construct several, this, this, this. If you construct several this, okay, what do we call? বাংলায় জ্যা বলে, ইংলিশে কি বলে? Okay, যাই হোক। তো if you draw this, okay, and even if let's say you are drawing this, probably this is not the exact diameter, still a gap between the center, it is not passing through the center, this is passing through center, but see, let's say this you have found, you have constructed a line segment like this, which is very very close to, it is not exactly passing through the center, but very close to, and you are calculating the lengths of this line segments, out of which, let's say, the length of this one is maximum. Okay, and you can immediately approximate that the length of that diameter, the length of this line segment is the length of, approximately the length of the diameter. Okay, okay, so this is another way, just what I am doing. So, okay, let me remove this here. Okay, let it be. One way, what I am showing you is a very preliminary school level technique. Okay, here let's say we may find another way. Okay, another way is several, আচ্ছা, কি বলে? তো প্লিজ, জ্যার ইংলিশ কি কেউ বলতে পারবে? Diameter, I thought answer will come. Radius, chord, chord, chord. I आपको बोलना है, जिज्ञेस कुछ. Okay, so construct several chords. Okay, okay, um, okay. Here, okay. Uh, this is, an angular sector chords within angular sector. Okay, contains surely the center of the circle. Okay, several chords, and try. Okay, so do this for, you know large number of. Okay, then measure. Okay, so the measure the lengths of all the chords. Okay, measure the lengths of all the chords and find maximum among these. Okay, the chord with max length, okay, can be, is an, okay, is an approximate, diameter of the circle. Okay, so this is our the first step. I mean, what we are trying to do, we are not knowing the radius, but still we are trying to manage somehow to measure the area of, compute the area of the circle. How? Let's say this is an approximation, and obviously this is it's not deterministic, it's non-deterministic. Okay, construct several, so diameter. Okay, so find radius from that diameter, let it be r dash. Okay, uh, a okay, and this is an approximation. Okay, a dash obviously, and this is an approximation. This is an approximation. Which is and obviously you can easily understand that this will be a good approximation if, okay, construct several chords, let's say n if n is large. Okay, hope you got it. Okay, so fine, this is one school level technique which we can use over here, and find an approximation to the area. But a good standard, I mean an engineering solution, okay, to this problem could be designed like this. The circle is inscribed inside a square, okay, of side a. Area of the square will be then a square. A is equal to a square. Now let's pick a point from S. Okay, let's pick a point P. Okay, from S. Maybe uh, maybe lying or outside C. Okay, so I am randomly picking up a point. Let's say I am picking up a point here. Let's say this point. So this point is outside the circle but inside the square. I may pick another point over here which is lying inside the circle. I am picking up that point from the circle, and that is also from the square, right? Fine. Now interested on finding the probability that P selected from C. Okay. So can you give me it? And it's a question. It's a very important question, very standard question when you in your high school level, class 11, 12 standard question. This is okay. So if I am selecting a point P randomly from the square, that point may be taken from the circle, may not be taken from the circle. Okay, this is the situation where I have selected a point from the square, but it is lying outside the circle, and this is that point which is taken in from a square and it is lying inside the circle. So we have two scenarios. So can you tell me what is the what can be the probability that the P point selected is taken from the circle C? Can you tell me anything? Right. Okay. So probability that P belongs to, okay, so probability that P belongs to Uh, okay, so circle of area divided by area of square. But I do not know the area of the circle. That's what I am trying to compute. So if I am using the area circle, why should I calculate area circle? Okay, so what I am trying to calculate, that I am using. So that is one thing. So probability of see how to compute this. Okay, so before that, let's define here. Let's define here R, probability that P is um, C of experiments, okay, in which P, when selected, comes from capital C, and let uh, n be the total number of experiments. Okay, so this I can do. If I randomly select a point P, I can check whether that point is lying inside the circle or not. Okay, so if I am given a circle, so that I can check. Okay, so that is C. The small c is the number of experiments in which P when selected comes from C, the circle. And suppose n is the total number of experiments. So out of n number of experiments, in C number of experiments, we found that P has been selected from the circle. So immediately I can say that the probability that P belongs to C is equal to C by N. Okay, and then we can say that then we can say that we can have probability A suffix, you told me that probability of P belongs to C equal to area circle divided by area of square. So in the next line, what we can write, A of C probability that P belongs to C by A. So this is what we can model. Okay. So there comes a non-deterministic algorithm, okay, to compute the area of a circle. AC equal to probability. So you can compute this probability. It's in your hand, okay, and you know this AS. So multiply this, you can find an approximate answer of Okay, so this is not an exact answer. Obviously, this is an approximate. An approximation solution to the problem using non-deterministic, and this algorithm will be termed as an approximation algorithm. Fine, approximation algorithm. So I hope you are convinced enough, and we have also done this thing, right? But still, somehow we have a problem. The problem is this. So what's the big deal in this algorithm? We are only finding area of a circle. Now, the above, what we can generalize, we can formulate more generalized problem statement as what is the problem statement? That is, problem statement is to a problem is to determine or to compute, okay, okay, area of shape, area of a region having non-regular shape. Okay, for example, right. So the example is like something like this. Okay, so let's say this is a region of which area is to be found. Okay, and this is the technique. So this is the region R, for example. Okay, and this is your square S. Okay, so in this case, the area can be found in this way. The area of, okay, let me write S R is equal to probability point P belongs to, okay, and this method has been proposed. This method is as this popular method, the very popular method. Popular method kind of uh, called actually approximation algorithms. Okay, yes, that's fine. So it's a well-known problem and well-defined problem. It's not like my thinking; it's already there. Forget about this. So we hope we like the topic. Okay. So we may have some problem of which exact solution finding is very difficult. In that case, we may go for the approximation. That's why approximation algorithms are coming into the picture. Okay. And this is in terms of finding the solution. Okay. So if okay, another thing which I want to mention in the module 4 when we discussed about computability classes of several problems AP, NP hard and NP complete. Okay, so mainly we restricted ourselves. No, it's an example, it's a motivational example. Okay, why we should go for an approximation algorithm. Okay, this is a very simple example to make you motivated. Okay, so it's not about area. Okay, now the case is means we are given a problem and then we are trying to find a solution. So think this problem as that problem. We are given a problem and we have to find a solution. So how to find a solution? But I can't find the exact solution, but at least I can find an approximate solution to that problem. That's why approximation algorithms are coming into the picture. Okay, and this is nothing but an example. Okay, now the case is while discussing about compatibility classes of problems, NP hard or NP complete, we restricted ourselves to only decision problems. Okay, and still we have seen that tackling with decision problems are very difficult, really very difficult, right? So given a graph, whether that graph is containing a clique or not, containing a Hamiltonian circuit or Hamiltonian cycle or not, okay, a vertex cover or not, etc. These problems are very difficult. We have already proved that these are NP hard problems, even NP complete problems. Okay, they require non-deterministic algorithms and they can be solved in polynomial time. So these decision problems. Now what about the corresponding optimization problems? We have a decision problem that given a graph, we have to determine whether that graph G is containing a clique or not. Yes or no, that's the answer we should have in the output. But the corresponding optimization problem is given a graph G, okay, we have to determine whether that graph G contains a maximum clique of size this or not. Let's say maximum clique of size k. Is it there present in the graph? So those optimization problems are not possible to, usually not possible to compute in polynomial time. Okay, they normally requires exponential time complexity. Okay, so we can't wait. That means the algorithms are very standard algorithms. Okay, so finding maximum clique in a graph is a very standard algorithm, but its time complexity is very poor, exponential time complexity. Okay, now that means in computational time aspect, if it is possible to reduce the computational time using an approximation algorithm, then it would be better. That's why the second aspect of using approximation algorithm is to uh, possibly reduce the computational time. That is, if it is possible, we can design a non-deterministic approximate algorithm. Early in the model 4, we talked about only non-deterministic algorithm. Here another term comes into the picture, non-deterministic approximate algorithm, which can follow a much lower time complexity. Specific usually order of 1, order of n, order of n square. Order of 1 is not possible. Order of n, order of n square. That means non-deterministic, okay, approximation polynomial time based algorithm. So this is our next concern to think about. Okay, so what we are thinking now are now towards non-deterministic, okay, non-deterministic um, polynomial time. So far, this is NP hard, NP hard, okay, NP complete, polynomial time. Then approximation. Okay, the problems NP, non-deterministic polynomial time, NP hard, approximation algorithms. Algorithms. So this is our next thing to move on. Non-deterministic polynomial time. Earlier, we didn't have any non-deterministic, I mean, polynomial time algorithms, which are NP hard. All the optimization problems means to usually usually handle the tackle, you know, the NP hard optimization. Minimum vertex in graph G. Okay, etc. There are many more. Okay, so now this is our thing. Okay, so motivation with example, another example with two. So already we have, this is our first example. First example, computing area of a region. Next, we have another thing. It's a okay. Let's say we are given a DNA formula. Let DNA formula be f of x1 CR. Okay, in number of classes we have. Then here we have right where you know from CI to from let it be bar, let here so this is arbitrary I. Okay. So this is a DNA formula. Now we can little bit analyze this. If n equal to 3, n equal to 3, okay. So how many assignments are possible which can satisfy this DNA formula capital? That number of assignments is called as DNF counting. Okay, so in that case, yes, the answer is correct. So if n equal to 3, we may find maximum number of assignments satisfying f is 27. 3 to the power 3, that is 27. Okay. Um, 8. Why 27? It's 8. 8. 2 to the power 3. Okay. So x1, x2, x3. That means using x2, x1, x2, x3. 8. We may have 2 to the power 3. That is total 8 number of assignments possible. And maximum all those assignments can actually satisfy the given formula capital F. Okay, so that and the number of assignments, so DNF counting DNF counting is equal to 8 full stop. Okay. So in general DNF counting okay DNF counting is equal to big O of 2 to the power of DNF of this. So so this is a problem. You have to solve this. You have to find the DNF counting, okay, for a given DNF formula, okay, and it follows a time complexity order of 2 to the power, which is exponential. So this is an exponential time complexity. So not, acceptable. Exponential, exponential time complexity. But if it is possible, so next our intention is now moving towards now if it's possible to design an approximate algorithm capital A generates an output let's say y that is an approximation to exact DNF counting. Exact DNF. Okay. Approximate algorithm A in polynomial time. Polynomial time means such as polynomial time means either in order of n or order of n square. So instead of order of n to the power of n, we are trying to design an algorithm which requires time complexity order of n or order of n square. And still that algorithm can produce an output y which is very close enough to the exact DNF counting. So why not we take this approximate algorithm capital A? We should go for this. I think this is the breakthrough of the motivation which can motivate you. Yes, we have to study about approximation algorithm. Okay, for to tackle this kind of problem. And if all the optimization problems which are in general NP-hard can't be tackled within polynomial time complexity, they requires exponential time complexity. In that, and those are very important concepts: finding maximum click, minimum vertex cover, maximum matching, independent set. Okay, I mean all the all the possible, the number of all Hamiltonian cycles. Okay, so all these are very important problem. These have to be solved, but they requires in general exponential time high time complexity. Then approximation of algorithms come into the picture, which reduces which are designed in polynomial time. Okay, that means in order of n, in order of n square, in some partial exponential time, order of n to the power, let's say 3 by 2, like that. Okay, so in this polynomial time complexity, it is possible people have designed some approximation algorithms, and still they are generating very good approximation results. That's why we have to study about approximation algorithms. Okay, so let me complete this thing. We want to wrap up today. Okay, so let me do this thing, complete this example. So a mathematician and computer scientist have already designed an approximation capital A, okay, which can compute an approximate DNF counting. Okay, let's say the output is y. The algorithm approximate algorithm A is generating an output y, which is close to DNF counting, and this equation y is guaranteed. প্রশ্ন হচ্ছে এটা যে ডিএনএফ কাউন্টিং এর আদৌ একটা ভালো অ্যাপ্রক্সিমেশন, তার বলতে পারো কি গ্যারান্টি আছে, এরকম একটা কথা বলতে চাইছি। ওকে, সো দিস অ্যাপ্রক্সিমেশন ওয়াই ইজ গ্যারান্টেড, the probability, obviously probability is coming. Okay, so with the probability, uh, 1 minus epsilon into a less than or equals to DNF counting. Okay, so DNF counting, okay, let's call it D. So DNF counting, the exact value of DNF counting is D. Okay, so 1 minus epsilon D less than or equal to y less than or equal to 1 plus epsilon okay, then this language will be with the probability such that 1 minus epsilon D is less than or equal to y, this. Okay, so where D is a positive constant, D, sorry, E, epsilon is a positive constant, is some positive constant. Okay, and in that case and I will talk about more elaborately in the next class. Epsilon approximation algorithm. It's called an epsilon approximation polynomial time epsilon approximation algorithm. Fully right. Okay. This is also fully. So in that case, A is called a fully polynomial time epsilon approximation algorithm. Okay. So this is my closing note for today's class. What we have done. So why we are studying approximation algorithm, etc., etc. And this is a most advanced topic. I mean, in today's scenario, people are doing research in this field. This becomes more prominent nowadays. In coding, Python has become a very emerging topic. So in case of algorithm, approximation algorithm, randomized algorithm, these have become the more prominent research topics. Okay, in algorithm field. Okay. Okay, if you have any question, you can ask me. It will be deterministic or not? Yes, obviously non-deterministic. We are talking about NP-hard problems. Okay, we are talking about NP-hard problems. I mean, more generally, the optimization problems. Okay, so it's already 1:42. So if we have to wrap up, we do not have any time. Otherwise, I could have shown you some example, one or two example, known example, 0 by 1 knapsack problem, etc., etc., maximum click problem. Okay, okay, we will do in the next class. Any other question you can ask me. Books, yes, reverse time I can share. Horvitz Sahani to already you have. Yes, reverse time I can share. Okay. Anything else? But in the time, book will not help you. Okay, books will not help you. I mean, I mean, while discussing about competitivity classes of algorithms, okay, so I followed that Sahani book, but it's not good as a beginner. Okay, so, so try to save your time. Anything else? Okay, we stop the recording.